This is the second lecture of Logic and the Set Theory in fall semester 2014. In this lecture, we will talk about arguments in the Notes book, chapter 1, argument diagrams there, argument evaluation in chapter 2 of the note, and fallacies. So we will discuss what arguments are and discuss some fallacies of the arguments. So this is just a reminder of K elements. So there are some helpful books. These are what you call rhetorics book. So this is not yet logic, but something related to logic before it was developed. So also see Plato again for other resources. Okay, so what is an argument? Argument is an attempt to convince someone of certain beliefs. This was developed by ancient rhetorics by Greek sophists, Roman orators, Cicero, for example, and Arab philosophers and Chinese philosophers. Logicians or school of name was a Chinese philosophical school that grew out of Mohism during the warring state period. And Confucius' arguments are mainly about how to bring the humane natural compulses out of anyone. And Indian logic is of course very developed and complete. Buddhism, it has a form of logic that the Western people learned about it mostly from the Japanese philosophers who wrote in English. Mostly these develop much emotional components called seizing the moment. But the Socratic method is different. So it examines the people's arguments and check whether the terms used have definitions, and so if the terms are not undefined, how is this used, and you will try to find the self-contradictions in the reasoning. Socratic method can be used constructively to produce sound reasoning, and of course Plato condemned the sophist who does not use this kind of sound method of finding arguments. So Aristotelian syllogism is an ancient form of formal logic which Aristotle developed and used in classical times from the Greek to even to 17th century. But now it is superseded by the logic of Frege and Russell, and the modern form of logic is a little bit different from Aristotelian syllogism. In fact, the 17th century English philosopher found some kind of mistake in it. Aristotle also wrote Rhetoric, so this is a book to the Alexander the Great, and there are also books by the sophists. So these all are concerned with arguments. So what is the modern rhetoric? In modern times, we just use, we just use the facts. So majority of the people form certain opinions, and they are considered facts. So also we use examples. Mathematical arguments are limited to logical steps only. So this is much distinctive. One follows the logic of Russell and Frege as the only valid forms of the argument. This is called the formal logic, and it is the content of the Notes book from chapter 3 to 7. Informal logic is an attempt to develop logic to assess, analyze, and improve ordinary language or everyday reasoning. It is not really a formal logic, and in some sense deficient. So let's consider these some arguments. So all humans are mortal. Socrates is human, therefore Socrates is mortal. So for example, if you accept these first two statements, then there is absolutely no way to avoid the third statement. You cannot find any way to deny the third one if you accept these two. Okay. Let's look at the second argument. Since the US Federal Reserve has issued too much money, there will be inflation. China has many intelligent people, thus China must soon become very rich. Okay, so these two so if you look at these three arguments, so the first one is the only right argument. So that's because for the second argument, so if the Federal Reserve issued a lot of money, but the people does not use it, then there cannot be inflation. Okay, and the third argument, okay, so many intelligent people can just waste their time and efforts having some needless arguments all the time and fighting among themselves, and they do not contribute anything to economy. Okay, so this will also make third argument be false. Okay, so only the first argument you cannot really avoid the validity of the third part without if you accept these two. So arguments involve premises beginning with such as words such as for, since, because, assuming that, and then there's a conclusion. It always starts with such words as therefore, thus, hence, accordingly. Okay. So some exercises, arguments has to be put in order of premises and then the conclusion. So one often needs to break down the sentences into atomic pieces. This means that you break down until no further decomposition can be done. Linguistically always possible. Okay? So if you look at the language, then you can break them apart always into atomic facts. Okay? So for example, square root cannot be written as a ratio of two integers. Every rational number is expressible as a ratio of two integers. The square root of 2 is not a rational number. So in this argument, each of these statements cannot be broken down any further. Okay? So these are atomic sentences, and it is a valid argument. So let's look at what the argument diagram means. So you label the atomic sentences, and you group the atomic sentences into a group that implies another atomic sentence, excluding any sentence that is not needed. Okay? So result has to have a null cycle for the argument to be valid. Outside the formal logic, one can draw also argument diagrams. So let me look at the example. So Seoul has most resources of Korea. People need resources to be in their city. Therefore, many people came to Seoul. And Seoul has too much population. The large population density in Seoul creates problems. Seoul should not have problems. So we must disperse the population to other places. So in this argument, it looks like this. Okay. So 1 and 2. So 1 and 2. Seoul has most resources in Korea. Okay. Implies 3. So therefore, many people came here. And many people came here implies too much population, 3 to 4. And large population density, and Seoul has many, thus should not have problem. So if you combine that, you should get 7. Okay? So if you remove any one of these, then you cannot get 7 here, and if you remove 1 or 2, then you cannot get 3. Okay? So this is the diagram. It has no cycle. So China must grow fast, or there will be instabilities. China must not become unstable. If a large country becomes unstable, then the nearby country suffers. China is large. South Korea is a nearby country. South Korea must not suffer. Therefore, China must grow fast. Okay? So in this diagram, you see 3, 4, and 5 together implies 2. Okay? So if you remove any one of these, we cannot get 2. Okay? So therefore, we get 2, and then 2 plus 1 must not suffer. Stable implies 7. Okay? So 2 is must not become stable, or 2 implies 7. Okay? So therefore, this is the argument diagram here. So argument evaluation is mostly in informal logic. Truth of the premises are important. Deductive argument is that if all the premises are true, then the conclusion must be true. Okay? So the conclusion is necessary. Inductive argument is strong or weak one is that the conclusion is not necessary but open with a large probability. So for example, you say the sun has been rising for thousands of years, therefore it will rise tomorrow. So that will be the inductive argument. So valid arguments are the only deductive arguments. Invalid arguments are non-deductive arguments. It also includes the inductive ones. Okay. So in fact, any conclusion follows deductively from inconsistent premises. Okay. So if you make a wrong premise or contradictory premise, then you can prove anything. So we will learn about this in this course. So for example, some pigs have wings, all wings sing, therefore pigs sing. Okay, so this is a deductive and valid argument. All mathematical theorems are true. Black-Scholes equation is a mathematical theorem. Therefore, Black-Scholes equation is always true under all situations. So what is false here? Okay, so this is true, but this is not true because equation itself is not a mathematical theorem. Equation with the condition when the equation holds is the mathematical theorem. So therefore, third, this is false premise. So therefore, this is a wrong conclusion. You also see there's a book called the Black Swan Theory, okay, by Nassim Nicholas Taleb, when the Black-Scholes equation did not hold because there were lots of very strange circumstances around it. So therefore, you cannot always assume that this equation holds all the time. Okay, so in the next section we will talk about fallacies, but this will be the first part of the second lecture. We will continue to the second part.